everyone, this is Rkhan and today I'm going to do my presentation on SSH. This is for ISA4220 for Professor Green, fall semester 2017. So the topic of discussion for today's presentation are going to be SSH, and then we'll jump on and I'll talk about some of the hardening techniques for SSH. So here I'll give you a little overview on SSH. So what is SSH? SSH stands for Secure Shell, which is a cryptographic network protocol for operating network services securely over an unsecure network. It is important to note that it's an application layer protocol which is in the 7th layer of OSI model. The application layer includes several other services such as SMTP, file transfer, web surfing, web chat, email client, network data sharing, virtual terminals, and various file and data operations. It's important to note that SSH connects from client applications such as POTI to an SSH server such as OpenSSH server. SSH was designed to be a replacement for Telnet, which is also an application layer protocol. SSH became a replacement due to security concerns in Telnet. SSH can be used to transmit data, commands, text, and even files with the use of SFTP, which secure file transfer protocol. It is widely supported on different platforms such as Windows and Linux. There are two major versions of SSH. The two major versions of SSH, the first one outdated version, which is version 1, and the newer one is version 2. SSH version 1 supports several methods of authentication, notably RSA-based host authentication and another method involving RSA-based authentication using an application of public key cryptography. SSH version 2 is similar and in the default implementation will attempt to validate via method that can be described as also being host-based. Host-based authentication is essentially authentication occurring on behalf of a host machine making use of users, in which authentication means are housed in the host therein. If host-based validation fails or is avoided, then another method is sought out via encryption. Encryption around SSH. To accomplish encryption, SSH uses a confidentiality methodology known as public key cryptography, also often associated with the concept of public key infrastructure, which is also called PKI. Public key cryptography is an application of what is known as asymmetric encryption. In public key cryptography, there exists a pair of keys with opposite functions, hence the asymmetric aspect. One key is capable of encryption, which the other is capable of decryption. These are typically also referred to as private key and public key. The sender of the information receiver receives the target recipient's public key and uses it to encrypt data for transfer that is susceptible to be decrypted. Specifically from the private key being held by the recipient. The recipient is then able to receive the payload that has been encrypted with their own public key, which was supplied to the sender prior to the transfer, and then they are able to decrypt it using their own private key. SSH key certificate. The first and the foremost is the privacy of communication. This means the connection which provides a remote shell login must be encrypted to prevent eavesdropping. There must be a mechanism to check whether the data sent by either party is not alerted or tampered with. In short, integrity check is a must. Identifier of both server and the client must be provided to each other to establish a proper authentication. A wonderful thing about SSH is the fact it incorporates all above mentioned characteristics in addition to some unique features of its own. So here on this slide, we'll talk about some of the hardening techniques for SSH. The first one is disable root SSH logon. To avoid unwanted remote access of the remote account regarding SSH, it is important that you disable root SSH login. By having the root account disabled, it will add another layer of protection to our host machine that will be granting terminal access via SSH. The next one on our slide is create SSH warning banner messages, detailing security policy and notifying potential users of the intended constraints and contacts of the provided host machine terminal access. Like many other simple modifications regarding the display of text messages in terminal or any other editor can be used. The next one on our slide is implement public key authentication. You know, and I know password sucks. They are a constant source of security problems. In many, current environments, if you look at, it's a big problem. And most intrusions can at most point be linked to cracking or stealing of a password. Public key authentication will allow for the authentication of a user seeking terminal access in a way that is immune to many of the faults faced by its alternative. Plain text visibility issue in Telnet, brute force attack, and other lower effort strategies utilized to circumvent password authentication. It is unsniffable, that's one advantage. During an authentication attempt, the SSH server verifies that you know the private key by checking a signature. So there's a valid signature there. This signature will not only help this signature will not help anyone in figuring out what your private key is. So it's safe to connect to untrusted hosts that may have backdoors. Moreover, private key authentication is not replayable. As part of the key exchange, the session ID, which is it's called, is used in sign payload. A computer that makes a man-in-the-middle attacks between you and the real server will not be able to authenticate to the remote host, even if you are override the host key mismatch warning message. The next one on our slide is use SSH agent. An SSH agent is a program that runs in the background whose role is to keep private keys in memory and issue signing operations to the programs in need. There are a few different agents. OpenSSH agent, there's another one called GNOME SSH agent, there's Pagent, etc. But they work more or less the same. The agent starts with the session, sets an environment variable with Unix socket to the agent daemon. You can then add list or remove keys from the agent. OpenSSH will automatically use the agent if there is one. And that's all there's to it. I hope you guys enjoyed. Thank you for listening.